Welcome back to Autodesk Inventor Automation Academy. Today, we are going to be going over component placement. I'm Philip Cox, Senior Application Engineer, and let's just dive right into it. So, in placing components today, we're going to keep it really simple and straightforward. We're going to be looking at how to get a part file select within several different types of here we have a flywheel part files, and then how to pick a rotation matrix or a translation matrix in placing that. So here's kind of the code we're going to be looking at. We're going to be doing this inside of an add-in. You can of course do this inside of iLogic as well, but here we're going to have it as part of a UI button click that we're going to go through and grab top level assembly, component definitions, and then we're going to use a select case here to pick out what our part name is going to be based on a combo box that the user is going to select on our form. And then once we have that, we also need to set what our rotation is going to be. The user can select around the y-axis. And then once we're done with that, we're going to just double check that nothing is existing beforehand and delete it if it needs to be deleted, and place our component, our flywheel. So let's go ahead and dive into the code and how this looks. First, we'll pull over our flywheel here, and we're going to open up our little sample UI, very simple. We can select what type of flywheel we want and what rotation, and hit build. Now we'll delete the one we had there before, and it places the next one. And what it's basically doing is getting a string, going searching for a part, and then adding that part, and of course setting up the matrix to add that part. So let's look at what happens when we hit that build button. Pop up the code, bring it over. Okay, so on our build button here in Visual Studio, we're going to be handling this click. And what we're going to be doing is first we need to grab the assembly because we're going to be placing this component inside that assembly. So we grab the top level assembly doc by grabbing the G Inventor application. This is a global that is set in your standard add-in server. So if I'll go ahead and close Inventor here, stop us from running, and we'll go look at standard add-in server. So here in our standard add-in server, if you remember in previous videos when we set up add-ins, we went in and added buttons and triggered forms in here. Well, now one thing that is already provided for us is a module of globals. These are variables that you can access throughout your application. And one of them is the Inventor application. So we're going to use that right now. Now I've added one just below here, which is a project directory. And this will be useful for setting up where our files are kept. So you can see I made a folder here at C KVA assemblies. That's going to be where our files are. And so I can easily, wherever I am, grab that. So now if we go back, you can see we have that Inventor application. We're going to get the active document. Now in this case, we know that it's going to be an assembly. You might not know that in your application, so that's one thing to be careful of. But we're going to put it into an assembly document. We're going to grab the component definition off of the assembly document, and that component definition is going to allow us to access to a lot of different things that we're going to need further down in the code. But first, we're going to set up a select case just to pick our file name. So we have a combo box. If I pull up the form here that we've made, and inside the items, I've just typed out basic, spoked, and a holy one, so that we can reference those. And I have made versions of these files in Windows Explorer here. So if I pull that up, I have a flywheels folder here where you can see we have the flywheel, basic one, the holy, and the spoked one, all within a flywheels folder. So those, we can get the combo box selected item, store it as a string. Then I'm going to dim up a part name. I'll instantiate it, set it to the basic one for starters, and then we'll do a select case, and based on what we're pulling off of that combo box. So in the case that the combo box says basic, we're going to get the part file name, which is the same as what we made it in the first place. If it's spoked, then we'll get this different. And you'll notice that we're getting just here part name plus the backslash, because we're going to append it onto something already existing. And same thing with the one that reads holy. Okay, so that sets up the part name. We'll do the same thing for grabbing whatever the user puts in as rotation. Now you can do this more complex. This is a very simple example, but here we're reading off whether the rotation combo box is 0, 45, 90, and then we'll actually convert that into radians for our rotation around Y. You could put a text box where they put in the actual numbers, but this was a simple way to show. Okay, so next we need to go find if there's any component that has engine flywheel in the name and get rid of it. So to swap off, you could do a replace here for ease. We're just going to for loop through the occurrences. Check each component name, see if it contains engine flywheel. And then if it does, go ahead and set that to this existing flywheel component occurrence. And then if that's not nothing, delete it. So that will delete our existing one so we don't pile them on top of each other.
Hey everyone, if you're finding value in this course, I'd encourage you to join KETIV Virtual Academy. It's where we bring together a growing community of engineers, nearly 40,000 strong, to share ideas, tools, best practices. Please join us at ketiv.com/KVA. Enjoy the rest of this video.
Now comes where we actually place the part. So here we're going to set up our full file name for the part. We'll get the project directory like we talked about before. So that's where we set it up over here. So it's going to be C KVA assemblies. Next, I put all of the flywheels in a folder called flywheels. So that's right there. And then we'll add on that flywheel part name, whatever one that the user picked based on the combo box. Then we need to make a matrix to place our part. So I'm going to make an object of transient geometry. This allows us to make points, also matrices. And so I'll call the transient geometry object .create matrix. This will make us a identity matrix. So 0, 0, 0, 0, right? Origin and no rotations. Next, I'm going to make the y-axis or a representation of the y-axis by just creating a vector and putting 0, 1, 0 so that we can rotate around the y-axis. If you want it to be around the x-axis, you do 1, 0, 0, z, 0, 0, 1. Next, we need to set our translation. So this is where you're going to place it in space. Currently, we're just going to place it on the origin. But if you wanted to, push it through space, you could do that. Now, normally what you would do, I actually have these backwards here. Let me flip these. Boop. you'd want to set your rotation around the y-axis because we're going to, if you look at the set rotation call, we take in the radians, we take in the axes that we want to rotate around, and we take the point we want to spin around too. And so if we did a translation beforehand, then we would be rotating in a very different way. And so generally, because we're rotating around the origin, you do your rotations first, and then you do your translations. In this case, we're not translating the thing anywhere, so it's not a big deal. But here we pass in those radians to rotate, and the y-axis and that origin point. Then we do our translations. So in this case, if we wanted to, do something slightly different, we could drop that in there. And then we need to add the component to the occurrences. So we're going to grab our assembly comp definition that we set up beforehand, grab all the occurrences on it, and add an occurrence. We'll pass in the full file name, starts at C and goes to whatever our flywheel part name is named. And then we pass in the matrix that we just made for positional. And that's going to give us this component occurrence that we've now placed in the assembly. I'm going to just go ahead and ground that. At this point, if you wanted to constrain it, you could do that. That's more complicated, but a lot of times you can just place it in space where you want it and then ground it. If you're not concerned about having accurate constraints, which in automations, a lot of times it doesn't matter if things are constrained. And that is how we place an occurrence. So now if I run this, we'll wait for Inventor to come up again. Okay. Pull Inventor over. We're going to start with a new assembly. And go to the tools where we put our button, launch the button. And now we can pick, well, I want the holy one and I want it turned at 90 degrees and hit build. And there we get it as it places it in. And we can, just make the shift here and it will update as we're deleting and replacing the part. And same thing with changing the type. So there is a simple example of how to place a component in Autodesk Inventor using the API in an add-in.
Real quick, before we keep going, one thing that comes up quite a bit is a lot of our customers feel like they have to do this on their own. We do this all the time. So if you want to learn more, you can go to KETIV.com/automation. If this is sparking ideas for you and you want to bounce them by our team or even engage with our team to help you deliver this internally, we're happy to help. So just please let us know. All right, let's jump back in.